All right, let's talk about a word that can make a lot of people just a little bit nervous: logarithms. But I promise, they're not just some scary, abstract math concept. They are a secret code for understanding the world all around us, from the chemistry happening in our own bodies to the stars way up in the sky. So let's just jump right in with an example you've definitely seen before. You've for sure seen a pH scale like this. On one end, you've got something intense like battery acid at a pH of 0.8, and way on the other end, lye at 14. But here's the wild part. In terms of actual, real-world acidity, that battery acid is millions of times more acidic than pure water. Which, kind of brings up a puzzle. How in the world do we cram that enormous, massive range into a neat, simple little scale that only goes from 0 to 14? Well, the answer is the absolute genius of logarithms. So today, we're not just going to define them, we're going to completely demystify the three fundamental laws that make them one of the most powerful tools in all of mathematics. Okay, so here's our game plan. We've already seen how logs pop up in our world. So we're going to start with a quick refresher on exponent rules, then we'll see how those rules translate directly into the three laws of logs. From there, we'll learn two new superpowers these laws give us: expanding and condensing. And we'll wrap it all up with a universal translator that lets you solve any log on any calculator.
So let's get into it with exponent rules, which I like to think of as the source code for logarithms. Because really, to get logs, you have to remember their inverse, their other half, exponents.
This right here, this is the whole key. If you can get this one concept, I promise everything else is going to click into place. A logarithm is just answering a question. It's asking, hey, what exponent do I need to raise this base to in order to get this other number? They're just two sides of the very same coin.
So here's our toolkit. You probably remember these guys from algebra, right? The product rule: when you multiply powers, you add the exponents. The quotient rule: when you divide, you subtract them. And the power rule: when you raise a power to another power, you multiply. Keep these three locked in your head because you are about to see them again, just in a clever disguise.
And here we are, the three laws of logs. And as you can see, they're really just our exponent rules wearing a trench coat and sunglasses. Each one has a perfect mirror image in the world of logarithms.
Let's start with rule number 1, the product rule. Remember how with exponents, multiplying two things meant you added their powers? Well, guess what? It's the exact same logic for logs. The logarithm of a product becomes the sum of the individual logs. See that? Multiplication on the inside becomes addition on the outside. So to put it a bit more formally, the product rule for logarithms lets you take a really complicated multiplication problem that's stuck inside a single log and just break it apart into a much simpler addition problem with two separate logs. It's an amazing tool for simplifying things. Okay, on to rule number 2. Just like division with exponents led to subtraction, we see the exact same pattern here. The log of a quotient, a fraction, becomes the log of the top minus the log of the bottom. Division inside becomes subtraction outside. It's a perfect parallel. And here's the official definition, just so we have it down. The quotient rule helps you simplify the logarithm of a fraction by rewriting it as the difference of two individual logarithms. And just like the product rule, it's all about breaking down tough problems into easier pieces. And finally, we get to the most elegant and maybe my favorite rule of all, the power rule. With exponents, raising a power to a power meant you multiply them. For logs, it's even cooler. If you have an exponent inside a logarithm, you can literally just grab it and pull it out front as a multiplier. That little n just hops right down in front. This is an incredibly useful trick for solving equations.
Let's just state that one formally. The power rule for logarithms rewrites the log of a power as the product of the exponent times the log of the base. This rule is the absolute key to solving for variables when they're trapped up in an exponent.
So, now that we have the rules, let's get to the fun part. What can we actually do with them? Well, welcome to expand and condense, your two brand new superpowers. These laws let us take one complicated logarithm and break it into simple little pieces. And they also let us take a bunch of simple pieces and build them back into one.
First up, let's talk about expanding. The game plan is super simple, and you'll usually want to follow this order. First, deal with any fractions using the quotient rule. Then, separate any multiplication using the product rule. And for the final step, use the power rule to bring any of those exponents down to the front. Let's see it in action. We're starting with the natural log of x to the fourth times y, all divided by 7.
First, the quotient rule splits that fraction, which gives us the natural log of x to the fourth times y minus the natural log of 7. Next, the product rule splits up that first term into the natural log of x to the fourth plus the natural log of y. And finally, the power rule lets us bring that 4 down, leaving us with our fully expanded answer, 4 times the natural log of x plus the natural log of y minus the natural log of 7.
Now for our other superpower, condensing. And you probably guessed it, this is just the reverse process. First, use the power rule to take any numbers out front and move them back up into the exponent. Then, use the product rule to squish any added logs together into a single product. Finally, use the quotient rule to combine any subtracted logs into one big fraction.
Let's look at an example. We have log base 3 of 5 plus log base 3 of 8 minus log base 3 of 2. Okay, the addition combines first. That becomes log base 3 of 5 times 8, which is just log base 3 of 40. Then the subtraction kicks in. That becomes log base 3 of 40 divided by 2, which simplifies to our final answer, log base 3 of 20. And just like that, 3 logs become 1.
Okay, time for a classic trick question. We know how to handle multiplication and division inside a log. But what about addition, like in the natural log of x squared plus y squared? Can we expand this?
And the answer is a big, flashing no. This is a super important point. The log laws only work for multiplication, division, and exponents times inside the log. There is no rule for a sum or a difference. It's a dead end. So whatever you do, don't fall into that trap.
All right, for our final section, let's look at what I like to call the universal log translator. See, most calculators only have a button for log base 10 and the natural log. So what do you do if you run into, say, log base 7?
You use this beautifully simple formula. The change of base formula lets you convert a log of any base a into a simple fraction of logs using a new base that your calculator actually understands. So log base a of m becomes the log of m divided by the log of a. It's a universal translator for any logarithm. So, to wrap this all up, here is your complete logarithm toolkit. The product rule turns multiplication into addition. The quotient rule turns division into subtraction. The power rule turns exponents into multipliers. And the change of base formula makes any log solvable on any calculator. That's it. These 4 rules are all you need.
We started this whole thing with the pH scale, but the decibel scale for sound, the Richter scale for earthquakes, and even the magnitude scale for how bright stars are, they all rely on logarithms to make sense of these huge ranges of numbers. So my final question to you is, now that you know the rules, where else are you going to spot them hiding in plain sight?